Okay. So guys, the first thing I need you to know is that all acids, their formulas always start with hydrogen. Okay? How do you recognize, if I just give you a formula, how would you recognize it as an acid? It's any compound that starts with H. Can you think of a compound that we interact with every single day of our lives that starts with H? Well, okay, yes, hydrogen, but how about something we drink? Water, okay? Water's formula, H2O, that starts with hydrogen. And yes, water is technically an acid. Now, water is also technically a base at the same time, so that's why it's neutral, it balances itself out. But by technical definitions, water is an acid, okay? All right, now, what does the word binary mean? Like if any of you are familiar with like computer coding, like binary code, what does binary mean? Yeah, two things, okay? A binary acid means hydrogen joined to just one other thing, okay? In most cases, we're talking about just one other element, like hydrogen and chlorine together, or hydrogen and just sulfur. That's a binary acid, okay? A binary acid is also defined as any acid that doesn't have oxygen in it. Like if it's just hydrogen and chlorine, there's no oxygen in it. We're going to see what makes a difference if an acid does have oxygen. We'll get to that. So how do you name these acids? Okay, well, first of all, you put this prefix, hydro, at the beginning of the word. Hydro, and then the root of the element that it's joined to, like if it's chlorine, we would say chloric acid. Okay, oops. So like, let's look at this example. If it's, I see that this is a binary acid because it's hydrogen and just one other element. So it's hydrochloric acid. Okay. And if we were in person and we were able to do labs all the time, this is the acid that we would be working with the most often. It's probably the cheapest, most effective acid. We use it a lot in our chemistry labs. Okay, let's try another one. Don't worry about that 2 that's there. That's not going to affect the name at all. What do you think this one is named? Try it. Tell me what you think. Yeah, hydrosulfuric. You got it. Now, and Elise, you're right. You might be tempted to say hydrosulfic, okay, because it's just the element is sulfur. So shouldn't it be hydrosulfic? It just isn't. Now, would I take off for that on a test? Probably not, but it is technically hydrosulfuric. Okay. I'm going to show you a little bit of a challenging one, but before we do that, let's try one more. How about this? Okay. Don't worry about the 3. It's not going to affect the name at all. What do you think this one would be named? Yeah, exactly, Ashley. Hydronitric acid. Exactly. Okay, now this next one that I'm going to put up, I would not put up on a test. It's just kind of to challenge you a little bit. Okay, you might look at that and say, wait a second. That's not hydrogen and just one other element. That's hydrogen and 2 other elements. technically speaking, ladies and gentlemen, this is considered a binary acid because it doesn't have oxygen in it. Again, I would not put this one on a test. I'm just trying to challenge you. Do you know the name of that polyatomic ion? Anybody know? Yeah, cyanide. Okay, the poison cyanide. This is exactly, Nolan, this is hydrocyanic acid. Okay, it's treated like a binary acid because it doesn't have oxygen in it. Okay, cyanide is, you know, what like wives use to kill their husbands and stuff like that. You always hear about that on like true crime stories. Okay, it's true, it happens. Just saying. I mean, I'm so glad this is being recorded. If I were going to poison somebody, I would not be so like, you know, basic and use cyanide. I mean, to be honest, they test for cyanide in any autopsy. Okay. I mean, right, Jeffrey? Right? You got to use something that they're not going to test for in the autopsy. Duh. I'm so glad this is being recorded. Okay. Yeah, right? I mean, long-term relationships get a little boring, right? You got to spice them up a little. I have problems. Okay, now, what if the acid isn't binary? What if it does have oxygen in it? Okay, and guys, for our purposes, that is mostly going to mean hydrogen linked to one of our polyatomic ions. Did you know, I mean, have you noticed that almost every single, not everyone, but almost every single polyatomic on your sheet has oxygen in it? Anybody notice that? Okay. So here's how you name an acid if it's an oxyacid. The key is, ladies and gentlemen, you've got to know the names of those polyatomic ions. So let's say hydrogen is joined to something, a polyatomic that ends in ATE, 8. Can you give me some examples of polyatomics that end in 8? Sulfate, chlorate, phosphate, yep. Okay, nitrate. If your polyatomic ends in 8, it becomes the root of that word, ic acid. Okay, so I'm going to use the one that Muhammad put up there. Chlorate becomes chloric acid. Please notice, guys, I did not put the prefix hydro in the name. Yeah, exactly, Chow. Okay, the prefix hydro is only for binary acids. If it's an oxyacid, it doesn't get that prefix. So chlorate becomes chloric acid. Okay, if your polyatomic ends in ite, give me some examples of ite polyatomics. Phosphite, give me some more. Sulfite, nitrite, okay? If it ends in ite, you take the ite off and replace it with OUS, us, acid, okay? And in your notes, ladies and gentlemen, I don't have it on the slide, but in your notes, I have this little like memory trick to help you remember this system. I want to go on record that I did not come up with this. My students years ago came up with it. Are you ready? It's in your notes. If you ate something gross, it will make you feel sick. Ate goes to ick. If you get in a fight, you need us. Okay, I know, it's dumb. It's stupid, I know. But it's just a little way to help you remember. Ate goes to ick, ite goes to us. Okay. And again, watch out for sulfur because you might be tempted to say like sulfic or sulfus. but it's sulfuric, sulfurous. Okay, but let's do some together. All right, listen carefully to what I ask you, ladies and gentlemen. What is the name of that polyatomic ion? Not the name of the acid. What is the name of that polyatomic? Chromate. 888. Okay, so how would we name this acid? Chromic. Yeah, exactly. Chromic acid. Okay. Chromic acid. Let's do another one. All right. Again, be careful. Listen to what I'm asking you. Tell me the name of that polyatomic ion. Okay. Perchlorate. So how would we name the acid? Perchloric. Exactly. Perchloric acid. Okay. All right. One more. So the H is part of the formula. It's in this case, on all these examples, Tao, you're right. It's not, we're not including that hydro prefix, but the fact that we're not including the prefix hydro tells us, hey, this is an oxyacid. It's not a binary acid. But the hydrogen still has to be in the formula because acids start with hydrogen. All acids have hydrogen in them. Okay, what's the name of this last one? The name of the polyatomic, NO2, is nitrite. So what do you think for the acid? Nitrous. Yeah, this is nitrous acid. Okay. You know, and somebody asked the question last class, you know, like, where do we see acids in our everyday lives? You know, you see citric acid when you eat any kind of fruit. Believe it or not, you have hydrochloric acid in your stomach contents. You also have something called peptic acid. Not to get gross and graphic, but I love true crime stories. There was a serial killer in the 90s named Jeffrey Dahmer, and he killed, I don't know how many, like 18 or so individuals. This is gross. He decided to get rid of the evidence of his, you know, killing these people by dissolving their bodies in these great big barrels, these big plastic barrels filled with sulfuric acid. It'll dissolve pretty much anything. I love true crime too. Yeah, he used sulfuric acid to dissolve the bodies of his victims, and it's super gross because it turns your body into like this, so gross, like this sort of sludge. Yuck. Yuck. Okay, free. All right, so let's say I give you the name hydrofluoric acid. Okay, guys, first of all, I'm gonna model for you the thought the thought process here. First things first, I see the word acid. What element do all acids begin with? You got it. Okay. Please look on your periodic table. When hydrogen becomes an ion, what charge does it carry? Just like all of its other brothers and sisters in the same column. Yeah. It carries a +1 charge. Okay. It's hydrofluoric. What element are we looking at here? Right. Okay. And because, guys, because it has that hydro prefix, what does that mean to you? What sort of acid is this? You got it. So it's hydrogen joined not to one of my polyatomics, but just to an individual element, and that element is fluorine. Okay, look on your periodic table. What is fluorine's charge? And then guess what? It's the same process. Swap and drop. There's my formula. Okay. Actually, I don't want to do this one. I want to do a different one. Let's do this one. Okay, sulfurous acid. Again, it's an acid, so I know that the first element involved is hydrogen with a +1 charge. Okay. There is no hydro prefix there. It's just sulfurous acid. Guys, what does that mean to you, that there is no hydro? Yep, it's an oxyacid. So in my mind, I say to myself, okay, I'm looking over at my polyatomic ion sheet. Now look here. It ends in us. What does that mean to you? It came from a polyatomic that ended with what? Ite. Remember, if you get in a fight, you need us. So what polyatomic are we talking about here? Yes, sulfite. And if you go and you find it, sulfite has that formula, and it carries a -2 charge. And from there, guys, it's the same process. So here's my final answer.